So beyond the limit definition of the derivative, you have rules. And your rules for derivatives to start with is, well, remember, a derivative finds the slope of a tangent line. So for this first rule, if you have f of x equals a constant c, well, then what that means overall is we have a horizontal line. And the slope of a horizontal line is 0, therefore the derivative f prime of x would equal 0. This is one way to display it over here. The other way you're going to see is d dx. That's the derivative based on x of a constant is equal to 0. It's the same idea. So you're going to start to see notations like f prime or y prime or dy dx or d of f of x dx. These are all notations to signify the derivative. And the reason why we have these is because two people came up with calculus. Newton is the one most know, and the other is Leibniz. The other big rule is when you have x to a power, when you take the derivative, it's going to be put the power in front and subtract 1 from that power. Again, put the power in front and subtract 1 from that power. And that's x to a number. The other rules kind of come together when you start practicing. If you have a constant times a function, you're just taking the derivative times that constant. If you're adding or subtracting, well, then you can take the derivatives separately as you add or subtract. For example, if you're asked to find the derivatives of the following, so given f of x, the derivative f prime of x, put the number in front, 6 times 4 is 24, x to the 3. The derivative of 12x, so you'd put the number in front, 12 times 1 is 12, but then it'd be x to the 0, so it's just 12, and the derivative of negative 7 is 0. For this next one, before you go ahead and start taking the derivative, rewrite it. A cube root is a 1/3 power, a square root is a 1/2 power. And now when we take the derivative, you put the power in front, you subtract 1 from the power. Plus, you put the power in front, you subtract 1 from the power. Now, typically, you don't want to have a negative power for final answers, so you'll bring it to the bottom and make it x to the 2/3 power, and then x to the 1/2 power, which they might rewrite as the square root of x at the very end. And that's how you'd write the derivative g prime of x. And this would just come with practice taking the derivatives. Because along with taking the derivatives, you're going to be asked applications of the derivative. So two examples to start is find the equation of a tangent line on the left and find the x values for horizontal tangents on the right. To find the equation of a tangent line, we're going to find a line. And to find a line, we need a point and we need a slope. Well, the point's going to come from the original function. The x value is 4, so you plug in f of 4 to find out what the y value is going to be. So there's a little bit of work here. So 4 cubed is 64, minus 5 times 4 squared is going to give you negative 16. The slope is going to come from the derivative. So you have to take the derivative here, put the power in front, subtract 1 from the power, minus put the power in front, subtract 1 from the power, and now we do f prime of 4. So that'll be 3 times 4 squared minus 10 times 4 will give you 8. Once you have point, once you have slope, point slope form of a line. I highly recommend going and doing y minus y1 equals m, x minus x1. That way you can just solve for y. So in this case, that would be, I'm going to erase it, you can write it down, y minus my y coordinate, so y minus negative 16 equals m, x minus my x coordinate. Y plus 16 equals 8x minus 32. Subtract the 16 over, and you'll get a final answer of, ooh, I can type this. Y equals 8x minus 48 for the final answer. Beautiful. There you go. Now, if you're asked to find a horizontal tangent is where the derivative is equal to 0, because I want where the slope is 0. So I would take the derivative over here instead, put the 4 in front, subtract 1 from the power. Put the 3 in front, subtract 1 from the power, and set it equal to 0, because I want to know where the slope is 0. Now we're doing some factoring. Take out a 12x squared, you're left with x minus 1. Set each factor equal to 0, and you get x equals 0 and x equals 1. And these are the x values for the horizontal tangent lines. And these are just two applications you're going to start to see when you're starting to take derivatives and apply another part to it, whether it be find the equation of a tangent line or find the x values for the horizontal tangent lines.